Here we are at 19a from our Chapter 2 targets. Now we're asked to write this following absolute value equation as a piecewise function. Now the first thing that we have to identify is actually our vertex, because that's pretty much what tells us our break in terms of our piecewise function. So to find the x value, we're going to go ahead and set what's inside of our absolute value equal to 0. So we have 1/2 x minus 5 is equal to 0. And now we're really just trying to solve for x. So we would add 5 to both sides, and then multiply both sides by 2. These end up canceling out, leaving us then with just x is equal to 10. So again, that is our x value. And our y value is pretty easy to find. We literally just drop down this 4, and that becomes our y value. So it looks like our vertex is 10, comma 4. And that's really how you always find a vertex for an absolute value equation. Now, the reason why we would look for that vertex again is to really see where is that break. Well, again, this x value 10 is where we would actually see the break, where our v goes from a negative line reaching then the vertex then to a positive line, or vice versa, where you have a positive equation line with a positive slope there reaching the vertex and then going down with the other part of our line. Now, because our a value here is negative, we should see a v going downward. All right. And that really helps us in determining where our negative and where our positive slopes are going to end up. So when we're talking about how to find actually the piecewise function, y then is going to be equal to our piecewise function. We know where our x is going to be less than 10 and x is larger than or equal to 10. So again, that's where that break occurs. But we're not really sure where our top function is and where our bottom function is. Well, keep in mind, we do have a v going upside down like this. And as a result, for any x value that is less than 10, in other words, this would be considered like your x value 10, we see that on the left side of that, for all those x values, we have a positive slope. Okay? We have a positive slope there. And when we're trying to find that positive slope, well, we have -2 times 1/2. That's what gives us our slope. So that's where we see for slopes plus and minus 1. Because again, there are two slopes, +1 and -1. But that's really going to determine then for our piecewise where we're going to add in that negative that we've seen from our definition. So again, our original function is y equals -2 times the absolute value of 1/2 x. I think it was plus 5, minus 5, plus 4. What we're going to do is pretty much just, instead of these absolute value bars, we're going to throw a set of parentheses around them. All right? And then for the other one, we have y is equal to -2 times 1/2 x minus 5 plus 4. So pretty much just rewriting the thing. But for the other one, we're going to add a -1 that it's being multiplied by. And what this -1 really does is it gives you your slope on both sides. That's what really gives us our positive and negative slope. One of these is going to give us a positive slope. The other is going to give us our negative slope. Now, it might be a little difficult to see right now what it is, but in a moment we should end up with seeing which one's our positive slope and which one's our negative slope. Well, over if we look at the green one and we distribute, we end up then with y is equal to negative 2 times a half comes out to be negative 1x. Negative 2 times negative 5 gives us positive 10 plus 4, in which case this just simplifies out to be y is equal to negative 1x plus 14. So there is our equation with our negative slope. Whereas over here, when we multiply our negative 1 times our negative 2, we end up then with positive 2 times 1/2 x minus 5 plus 4. Now distributing in that 2, we end up then with y is equal to 1x minus 10 plus 4. Combining our like terms, we end up then with y is equal to 1x minus 6. So here are now, again, our two lines. The question is which one is going to go on top and which one is going to go on bottom? Well, again, we have a V that's facing upside down like this. And again, that's because of our negative 2 in front. It pretty much just flips that V because he's negative. Now, when we're to the left of our vertex, we have that positive slope. So those are all of your x values that are less than your vertex 10. And as a result, that must be this guy with that positive slope of 1. So then this guy would have to be our left, this guy would have to be our right. And as a result, for our piecewise function, we have 1x, I want to say it was minus 6, yep, minus 6, and then negative 1x plus 14, yeah. And there is, again, our piecewise function. So right now I've gone ahead and just graphed this function in Desmos, and here in fact is what that image looks like. Now if I go ahead and enter in our other functions, we came out with x minus 6, and there you could even see that blue line is overlapping the red one. And then to get our other part of the piecewise function, we had negative x plus 14. And then there you can see where they are totally covering that red with both parts of that piecewise function. So again, this would be your piecewise function for 19A from our Chapter 2 targets.